So often scientists and engineers use special formatting to represent large numbers. This technique is typically called scientific notation, and we use it in power engineering and energy systems. We typically use metric units, so we're going to kind of combine those together into a little lecture here. The preceding sections have all referenced the SI system, or what's called the international system, or the metric system. The relationship between force, energy, and power can easily be seen by looking at the units used to represent these quantities. The basic unit of force in the SI system is, I hope you remember, it's the Newton, capital N after Isaac Newton. 1 Newton of force is needed to accelerate a mass of 1 kilogram over a distance of 1 meter in 1 second. So we can say 1 Newton is equal to kilogram meter per second squared. The basic unit of energy in the metric system is the joule. One joule of energy is equivalent to the exertion of 1 Newton of force over a distance of 1 meter. It's a Newton times a meter. Right? The basic unit of power is the watt. 1 watt is expended when 1 joule of energy flows in 1 second. So we can see the relationships between all these. Often, to account for very large or very small numbers when referring to newtons, joules, and watts, prefixes are added to metric units to denote multiples of 10 to be applied to the base unit. Each factor represents an order of magnitude change in the base unit, as shown here in this table. These aren't all of the energy unit conversion factors that are available, but these are the ones that are most common in energy systems. So we'll just go through them. So the first prefix is nano. Its symbol is a small n. Its factor is 10 to the minus 9. So if you see a small n in front of a number, it means multiply that number by 10 to the minus 9. The next one is, so I would say like nanowatts. The next is micro, such as microwatts. Its symbol is the Greek letter mu, lowercase mu, and it is 10 to the minus 6. So that one's very often used with distances, micrometers, things like that. Milli, you're probably familiar with milli, but it means 10 to the minus 3. Its prefix is a small m. Kilo, very, very common in power systems. We often talk about kilovolts, kiloamps, kilowatts. That's a small k, and it means multiply the number by 10 to the third. Mega, very common for the size of generators. Generators and power plants produce megawatts of power. Its symbol is a capital M, and it means to multiply by 10 to the sixth. And then becoming more and more common, especially when we talk about national scales of energy consumption, the unit giga, capital G, 10 to the 9. So let's do an example doing some energy conversion. So let's convert the power that we calculated in the previous example over into kilowatts. So all we have to do here is we take the power that we calculated, which was, if you recall, 2,613.3 watts, 2,613.3 watts, and I want to convert that to kilowatts. So what I know is that in 1 kilowatt, there is 10 to the third watts. 10 to the third is 10 times 10 times 10, or 1,000. So if I want to convert watts to kilowatts, I multiply by this fraction, and it gives me 2.6133 kilowatts.